registered today but didn't get their badge yet. There are just a couple of people, I think, that didn't get their badges because we were out, but we got them now, and that applies to apparently no one in the room. So, disregard.
Sure. Okay. Whatever you want to do. Are we live or something? Like, what's with the countdown thing?
Yeah, I want to time it.
5, 4.
All right. Hey, welcome to Breaking Ajax Web Applications. We've got Alex Stamos and Zane Lackey that are going to be presenting for you here in a minute. And from what I understand, looks like Zane might actually be releasing some O'Day, or at least cheery O'Day, with some Mickey's beer left over from Dan's talk. So if you can fire off a really good question, I'll make him chug the Cheerios and beer, or Beerios, I guess. So line up your questions ahead of time, and he's already committed to doing this, so don't let him weasel out of this. But a big round of applause for both Alex and Zane for breaking Ajax web apps.
That picture is just a little demonstration of why Dave was a little messed up this morning. So, anyway, so like he said, my name's Alex Stamos, and we're what? Oh, okay, yeah, actually. And this is a little talk about Ajax web apps. We've got 74 slides in 50 minutes, so I'm going to be skipping over a ton of stuff. But I'm really, still happy to take your guys' questions, just not stupid questions. Let's try to keep them good because we don't have a lot of time. So we'll just do a really, really quick introduction about Ajax technologies. Talk about how Ajax changes web attacks. We'll talk about several web attacks that are very different in detail. And then Zane's going to go through some of the popular Ajax frameworks that are out there and some of the security issues that may exist with them, as well as what kind of protections you get from them if you build your app on top of them. Who are we? We work for a little company called ISIC Partners up in San Francisco. And why do you care about this talk? Well, it's pretty obvious to anybody who reads the news, even not just security news, that Web 2.0 apps are going through a little bit of a renaissance of vulnerability. MySpace, the fact that the term cross-site scripting worm is part of the security parlance now, that's kind of a big deal. It's a big change from 2-3 years ago when nobody really cared about web application vulnerabilities. And so today we're hoping you walk away with a basic understanding of Ajax, although we don't have really any time to give that to you. So hopefully you came in with that. Knowledge about how Ajax changed web attacks. We're going to talk about some in-depth knowledge for some very interesting attacks. And we want you to form your own opinion on whether or not you can trust an Ajax framework to do security for you. So we're not trying to load that question at all. I want you to form your own opinion based upon the talk. And I just wanted to throw out some special thanks to some of the other folks at ISIC Partners who've done some good work. Amit Klein and Jeremiah Grossman do some excellent work in the Ajax field and post on the web app sec mailing list, which is a very good place. And Rich Canyon's at Google, little shout out. Send us your resumes. Okay, so what is Ajax? Well, first we'll start with a different buzzword, Web 2.0. This is a totally overloaded term. Mostly because if you're up in Palo Alto and you go into Spago and you say, I have an idea for a Web 2.0 social networking site with videos and I'm going to have Indian developers, somebody will hit you in the head with $5 million of Series A, right? One of the venture capitalists sitting there. It is way overused, it is way overloaded, and it's really not a technological term, right? Web 2.0 is more of an attitude change. And some of those attitudes that are different than the web was in 1996, 97, are ideas like user-created content, or in the case of user-pirated content. The idea of social networking. Web applications have had users for a long time, but it's pretty new that applications understand the relationship between their users, right? They used to just have admins and high-rights users and then a ton of low-rights users and not really an understanding of how those users matched up with each other and no differentiation about how much access those users would have into each other's information. Usually it's nothing, right? On most web applications, you shouldn't know anything about the other users on the site. And so the networking is a pretty big change to a security model. The idea of highly interactive GUIs, this is where a lot of the kind of Web 2.0 flashy stuff is. This is mostly a phallus measuring contest between Google and Microsoft and Yahoo to whoever can have the most flashy interactive GUI, even if it doesn't actually help you use the app. It's mostly just for playing around. They don't make any money doing this, right? Google Maps doesn't make any money for Google. It just looks cool, and people think Google's cool because you can scroll around and use the middle wheel. right? But that actually is a very interesting technological issue. But one of the most interesting things is that Web 2.0 has built into it the idea of mashups and plugins. The idea that a web page no longer comes from a single source. It comes from tons of sources. Sources that you may not trust. Sources that aren't companies anymore, but 12-year-olds in basements. And that should be of concern, and that changes the security model a lot. So like I said, Web 2.0 really doesn't use a lot of new technology in a lot of places, right? If you look at MySpace, they're really technologically boring sites. YouTube uses a lot of Flash to play video stuff, which is nothing new. It's just they're kind of now at the cusp of the point where people have enough bandwidth to handle that video streaming down to Flash, but they don't really use any AJAX technologies. And MySpace is horrible, and I'll show you an example in a second, right? MySpace sends people huge freaking chunks of HTML whenever you load anything. There's nothing interesting or technologically advanced about MySpace. It's just a very different but there are people that are doing different things. And those are the companies that are truly using AJAX technologies. Things like Google Maps, MSN Virtual Earth, Flickr, any of those interactive sites that work asynchronously, that have lots of interesting stuff going on. Those are true AJAX sites. And so I'm going to use the term Web 2.0 and AJAX, mostly because I'm lazy. Although every time I need somebody to count how many times I say Web 2.0, because I have to send Tim O'Reilly $1 apparently every time I say it. But when I say those things, I mean sites that do this stuff. Sites that use client-side executables to do the presentation layer. That's a big difference, right? The presentation layer in a web app used to be created on the server and sent down just to be rendered. There's a big difference between the compositing happening and the rendering happening on the client side. The presentation layer is moved to the client side in an AJAX app. The pages that use less than full page reloads to change content, that use data formats other than HTML, that in detail, and that usually interact asynchronously with a server. So this is the kind of things that really are, you don't actually have to have JavaScript or XML to do asynchronous JavaScript and XML, but it's these kind of things that actually categorize something as being an AJAX app. So for an example of two totally different Web 2.0 applications, one of them is MySpace. Who here has a MySpace page? It's okay, you can say it. That doesn't mean you're a child molester automatically. You're just probably a child molester. That's it? Only 4 or 5 people? Yeah, MySpace is pretty crazy. Their entire business model is cross-site scripting, right? They're saying, we're going to give you script from somebody else and some ads, and that's their business model. When you look at this web page, what's interesting about it that's different than a web page you would have seen in 1997 is that all of this content, about 80% of this content, was not created by somebody working at myspace.com. It wasn't created by a contractor working in India. It was created by a man who wears a bear suit Saturday mornings. Actually, I think Oski's usually a woman because Oski's like 5'2", but it's a woman who wears a bear suit put this web page together, right? When you go to this page, you are looking at executable code put together by Oski the bear. And that's different, right? Because this is not oskithebear.com up here, this is myspace.com. This is running the myspace.com document.domain. It can access the myspace.com cookies. Code running on this can pretend to be you on myspace.com. That's a big difference in how the web was supposed to be. Right? The whole web security model, which doesn't actually exist, but if the web security model did exist, the basic premise is that when you get code from a site, you trust it, right? But MySpace lets you do all kinds of crazy crap on your MySpace page, right? You can have your little interactive photo sharing thing. You can have your ripped off MP3 that you stole that you want to play for all your emo friends so they can cut their wrists to the newest music. No, you can do all kinds of crazy stuff on MySpace. It's a supported part of it that requires you to have tons of executable content that can download. And if you look at a MySpace request, it's a big, ugly-ass URL and a huge chunk of HTML. This is about a 20th of the page that came down for the Oski site. There's no multiple reloads. There's not lots of different connections. There's not a lot of interactive JavaScript. This is Web 1.0 with a Web 2.0 business model. A very different model is Google Maps. You can see here is a screenshot in the middle of Google Maps loading. It loads up images as single tiles, and it does all this stuff asynchronously. Google Maps is really what you're looking at here. This is not a web page coming from a server. This is a web page put together by JavaScript running on your machine that happens to get data from a server, which is a big difference, right? The presentation layer here, what is putting all this data together, is running on your machine, running within the security model of Google.com, and actually in this case it comes from Google.com. And the requests are not one big get and a huge response. There's tons and tons and tons of little gets and little responses. What is this? This is the entire response for this GET request from Google. What is this here? It's not HTML, is it? Right? If you just sent this, if you just put this URL into IE, you would just see this stuff printed out as text, right? But it's not getting to IE that way. What is this code right here? It's JavaScript. And what's GAD copyright? It's not defined here. I don't see a GAD copyright function. Where is that? It's a method that's already been loaded into the browser. This is called a JavaScript callback. This is a very popular way of doing AJAX. This is an extraordinarily insecure way of doing AJAX. And we'll talk about a couple reasons why. It's not a big deal in Google Maps because they have no security model, right? Everybody can get all the information. There's no users. There's no logins, nothing like that. If you do this on a bank site, you're toast. Okay, so why do you guys care? Why care about Web 2.0 security? Isn't Web 2.0 just like stupid things teenagers do all day? Well, a kid, a teenager. Okay, see, these are the oldest people in the room. Everybody look around. Right. So you guys care, obviously, because your teenagers are doing this day in and day out. But why do other people care? Well, Web 2.0, like I said, it's an attitude change. It's a real change in how people interact with the technology. When I was in high school, which was not an incredibly long time ago, the fact that I hung out with all my friends online in IRC made me ineligible to date, right? That cut me off from half the population. If I was gay, it'd probably cut me off from that population too, right? It's just ineligible to date. That was not a cool thing to do when you're in high school. If you were 17, I've got like a 13-year-old cousin who goes to this hip junior high down in Orange County. I think they have their own reality show. Every one of her friends has a MySpace page. Every one of them, in their entire interaction online, she friended me, right? I have a MySpace page mostly for testing purposes. It's not for child molesting, just so I can put this talk together. She friended me so I could see all the stuff they talk about. I can't even read. It's not English. It's some kind of amalgam of English using the Latin character set. But I don't know what they talk about. But all of their friends are online, and all of their interaction happens online through MySpace and IM. That's a huge difference. If MySpace had a field that said, give us your parents' social security number and bank account numbers, kids would probably put the money in, that information in, to get a page, right? Because they have no fear. They have no fear of the fact that they are letting the news corporation, owned by Rupert Murdoch, know all about their friends and all of the things they're interested in and all the kind of stuff they like to buy and all of, and who dated who and who's going steady with who at Laguna Miguel Junior High School, right? They're giving all that information away and they have no idea of who has access to it, and they really don't care. Because to them, you put anything on the web, everybody can get it, and that's how the world works. They don't expect privacy. They don't expect any security controls. That's a big deal. Because in 10 years, my little cousins are going to have jobs, and they're going to have bank accounts, and they're going to be getting mortgages and buying cars. And the way they interact with the web is going to be affected by how they're interacting with it now. This is interesting because these technologies always spread from the innovators to the traditionalists. Companies go out, they get lots of venture capital, and they burn it, creating new uses for the technology, right? YouTube is probably not going to go out of business. They're going to get bought. If they don't get bought, they're going to go out of business because they're burning money like crazy. But if they are doing that to create a new way that people interact with the web, other people with money are going to come in and copy that. The thing is that the innovators never care about security, right? MySpace never cared about security until they're on the front page of USA Today as being a place that child molesters hang out. And they still don't really care about security. They care about child molesters, right? They don't care about security like we think about it. When these technologies are used by financial institutions, like some of our customers have, healthcare, government, the government's talking about having a standardized AJAX framework to use on all their websites. At that point, we care a little bit more than just the MySpace world. Obviously, the bugs are affecting people now. So the bottom line, I read a thing about how if you put the conclusion of a presentation up front, everybody gets emotionally involved with the rest of your talk. So prepare to get emotionally involved, okay? We're all going to... Okay, how does AJAX change web apps? This is the conclusion. I'm going to go through it real fast because we'll go back through this in detail. Discovery, enumeration, parameter manipulation. This is the crappy part of a web pen test, but the part that always gets you a lot of bugs is finding all of the things a web application does and then trying them and doing what it's not supposed to do, right? This is things like changing the amount of money you pay for something in a web store, right? Who here bought something off the internet like in 1995? Did you pay the actual price for it, or did you get it for free? Yeah, that's right. It's okay that statute of limitations run out by now. Right, because everybody's shopping cart app on the web had little hidden fields that said the prices of all the items in your shopping cart. That's how they stored that state back then in 1995. They're not as dumb as that anymore, but there's still a lot of parameter manipulation attacks. These are hard to find. Just problems in which the application does something stupid when you ask it. In the Web 1.0 world, to find these bugs, you would have to log in with a valid login and spend all day playing with the site while recording all of your traffic to see all of the different things the website can do, right? If it's a bank application, you got to transfer money, and you have to go open a new account, and you have to go change your preferences. So you got to do all this stuff because you have to find out what all the URLs are and what all the parameters are before you can go back and then try all the stuff and do it poorly, right? Make sense? That was the only way you can do it, because the web application doesn't say up front, this is all the stuff I can do. You have to go through and click all the links, and that's why it's, web application scanners are really expensive, because they have to build in all this pseudo AI stuff to go through and click all those links and pretend to be a human being, right? Well, in Web 2.0, this is actually often a little easier. Now, it's harder in the way that there's a lot more ways to quote-unquote click on a link in an AJAX site than there is in the good old days. In the good old days, there were links, A tags, and there were form posts, and that was it. Those were the ways that you interacted with a website. And now there's tons of different things you can do in the JavaScript that cause communication on the back end. So it's harder to go through and automatically find all the links, but often you don't have to, because there is a method that most AJAX sites work by called AJAX proxying, by which they need to send down a huge list of all the methods that you have to call. And we'll give some examples of that later. So AJAX enumeration is a little harder from a technical standpoint, and all the web application scanners break. There's probably a SPY or a Sanctum person in here that would object to that, but they are all broken now by AJAX sites because they can't do the same kind of enumeration. But if you know what you're doing and you're a human being, this can become much easier. You can even do enumeration now without even logging in often. And we'll give some examples. Cross-site scripting, everybody knows what this is. In the good old days, there are two basic ways of doing cross-site scripting. You either create a new node in a website, right? Like if I'm in a discussion forum, and now I want to create a new script node, or I create a new style node, or something that has executable content in it. I do that by putting some brackets in and saying, this is my node, right? That was one of the big ways that you can do cross-site scripting in Web 1.0. The other big way was to break out of an argument inside of a node. So like if this is often for referrals, like A-links, right? That you just do a double quote, you break out, and then you do like an on mouse over. There's other ways people could do cross-site scripting, but those are the two big ones. In Web 2.0, this is much more complicated, because it used to be the only thing dynamic you got from a web server was the HTML, right? The HTML was all put together, and that was put together dynamically, and that's what the magic part of the web app was. Where now, there's all kinds of stuff that comes down from the web app. It can be JSON arrays, it can be JavaScript arrays, it can be XML, it can be executable JavaScript, it can be JavaScript callbacks. And all of those different things have different ways of putting cross-site scripting in them. And there's actually, instead of the one way you can do cross-site scripting, which is I write stuff into the HTML, there are now 4 or 5 different ways you can do cross-site scripting on JavaScript. The downside for attackers is you can't do script alert, I own your ass, /script, and as your standard test anymore, right? Because this doesn't catch most of the bugs on cross-site scripting for AJAX. But the good thing for attackers is there's a lot of, if you know what you're doing, there's a lot of different ways you can. Injection attacks, these are attacks against backend data query protocols like SQL, LDAP, XPath, XQuery. These are basically in AJAX. AJAX doesn't change much on the back end when we talk to database servers and we talk to login servers. What does change is that there is now an object serialization, not just downstream from the web server to the database server, but from the user's browser to the web server, right? It's no longer just a GET request or a POST request. It could be some a serialized data object like an XML array. Right. I already won, because I'm integrated to the Right, so I'm not talking about doing this with like a network man in the middle. I'm talking about what if I send you content that then, say you hit reply to my post, and that reply then includes my post, and now you put something that has XML content into your XML post. So it's like cross-site scripting, but I'm not sending script to you, I'm sending script that you're going to send back to the web server. I've seen this a couple of times, it's not that common, we're not going to talk about it in detail, because this is basically a work in, but if you have upstream from the web client to the web server, something like JSON or XML or something, you have to think about, make sure that those special characters don't get into that stream from bad guys. And cross-site request forgery. We'll talk about this in detail. This is my favorite it's not really new, but it's kind of new in people's minds, web attack. This is really, really bad in AJAX in some situations, and we'll talk about it in detail. Okay, any questions on the conclusion, which there should be, right, because I didn't give you the details of any of this stuff. But any questions before I get to the details? Okay, so this is the part we have to go through real fast, the background. Before there's Ajax, there's these iframes. You can load them hidden, and you can do stuff asynchronously. That's the old way of doing it. Now you have this thing called the XML HTTP request object. You can do it in Mozilla. You can do it in ActiveX. IE7 is now going to have this as a native object. If you guys care about this stuff, you can read the slides later. This is how you use the XML HTTP request object. What's good about it is that you can have arbitrary structure of content in XML HTTP request. You have to have name value pairs was the only way you used to be able to interact with the web server, right? Either name value pairs in a GET request or name value pairs in the body of a post, right? Those are the two only ways, and now XML HTTP request allows you to do lots of stuff. You can have any kind of arbitrary content going up and downstream. It can do all kinds of different stuff. You can do upstream, and this is upstream from the user to the web server. You could do all kinds of things. Oh, I'm sorry, we're talking downstream. So I've done an HTTP up using XML HTTP request, and now I get some stuff back. I can get back XML. I can get back full JavaScript, meaning JavaScript that by itself is totally legal and valid. This then gets wrapped in a JavaScript eval and runs within the context and then goes and updates the page. JavaScript arrays, which are just array functions that you come down, you declare some new arrays, and then the JavaScript goes back and checks its data structures to see what's changed. A type of JavaScript array is called JSON. This doesn't look like it, but this is execute JavaScript right there. That's a JavaScript literal. If you run this code in an eval, you will end up with a JavaScript array called zip codes with these as members. Atlas, which is Microsoft's custom framework, which looks just like JSON but is completely incompatible, which is shocking. Somebody embraced and extended JSON. And Google Web Toolkit, since we're lapping on Microsoft, Google Web Toolkit is actually completely incompatible with JSON and totally custom. It has nothing to do with anything else, and we'll talk about those in detail. Upstream, we have the classic things like our classic HTTP gets, right? You put a question mark and then a bunch of name value pairs with question marks separating them, right? Everybody's seen this. You can do posts, which means I have an URL like we saw before, like here, but in the body of the request, there are name value pairs like this. This is the traditional way of doing an HTML form. A lot of Ajax frameworks still simulate this, even if they're using XML HTTP request. We can do upstream SOAP. I've only seen this in practice in one situation. It was for an internal website. These people that make things like Siebel and SAP and PeopleSoft and all the internal big enterprise software, they don't like making clients for Linux and Mac OS and Windows and having to support all these clients, right? So they're moving over to JavaScript Ajax clients instead of having to support all these thick clients. And so one of the easy ways of doing that, do you guys want the lights on or off? Bow, wow, wow. Thank you. And so one ways to do that is because all these guys expose already a SOAP interface, is that you create a SOAP interface in JavaScript that then takes the SOAP and turns it into a web page. In this situation, the framework was about 1.2 megabytes. So it's something that you'd only do internal on switched 100 megabit, right? You would never do this to a commercial and external site, but we see it every once in a while. XML, this is a traditional way. This is often called a REST web service. Not a lot of people do this because it's so heavy duty. Okay, the bugs. So the first bug I talked about a little bit in detail already is method manipulation. Playing with parameters is an excellent attack. SQL injection is kind of BS. It's fun and you can do a lot of demos, and I shouldn't say this since somebody's doing a SQL injection thing tomorrow. But it's really hard to steal money with SQL injection, right? If you ever actually go to a bank and you see the people that are writing their J2EE enterprise web server, and you go and you'll see on the wall this huge piece of paper with a big chart on it. What's that chart on the wall? It's a database schema, right? And it's huge. Entire freaking wall for the database schema. And that's because banks and other financial institutions have very, very complicated databases. And it's not easy for them to use the database, right? So do you think it's easy for an attacker who doesn't have that chart on the wall to interact with the database in a way that actually moves money between accounts? No. SQL injection is fun if like a database is unhardened and you can break out and take control of the operating system. It's fun because you can do things like drop table and destroy the database and just cause damage. But it's really hard to take SQL injection and actually make money move, because you have to change a lot of numbers and a lot of different tables, and they all have to match up, or all of a sudden stored procedures and triggers and all this stuff start flipping out, and things just break. So it's easy to do damage, it's hard to steal money. It's easy to steal money with parameter manipulation, right? Because what you're doing is you're asking the web application to do it for you. You're saying, hi, I want you to transfer money, and this is against your rules, but for some reason you're not checking that rule. And then the application the work. And that poor soul who had to write the application and had the schema on the wall, they've already done all the programming for you, right? So people understand this is bad. I mean, this is kind of low-hanging fruit, you know, if you can just do things like ask for a negative amount of money to be transferred between accounts, which is an old attack, but it still happens every once in a while. And when it happens, it's an easy way of stealing the money. What is this number? Anybody know? Any idiot savants in here? This number? No. It's 2 to the 31 plus 1. This is a number that cannot be represented in a signed 32-bit integer, right? What happens if I put this number into a signed 32-bit integer? Maybe it turns into -1. Depends on whether it's 2's complement, right, or using the signature bit, the parity bit. So it matters on the actual implementation of how negative numbers are represented in the processor. But yeah, this will turn into a negative number. Maybe -1, maybe -2 to the 31. I'm not sure. But one of the, this is the kind of parameter manipulation attack that still happens, right? Say you have a web application, and it uses, the magic 64-bit Java integers that automatically size themselves, and it looks at this number and it says, I've got input filtering. I'm not supposed to let people transfer a negative amount of money. This is a positive number, right? Because in the Java integer, it is a positive number. That's huge, but that's not my problem, right? And then it sends that request to the system of record, which is some ancient AS400, right? Because banks don't actually do anything. Your account, all of your financial information is on the stuff IBM sold people in the 70s. Hate to break it to you, right? But it's the stuff in the basement that there's a guy with a gray ponytail who makes a ton of money, right? Because all of his compatriots have died or retired, and he takes care of this machine, and it's the system of record. I apologize to anybody here who's actually old enough to learn kicks, but anyway. So it sends this number, this huge number, back to AS400. AS400 represents it perhaps as a 31-bit signed integer. It becomes negative. It transfers a negative amount of money from one account to another, maybe -$5 million. And so your checking account has -$5 million in it, and your savings account has $5 million in it. And then you walk into a bank and you get a check cut for that $5 million in the savings account before all their stored procedures run and figure out that this is wrong, right? That's the kind of parameter manipulation stuff that actually happens. And this is a true story. We actually did steal $5 million. It turns out the Secret Service isn't like that. They would rather you do a proof of concept with like $1. But so it's an argument for using dev systems or QA systems during pen tests. But anyway, parameter manipulation still exists. Is there an easier way to do parameter manipulation in AJAX? Well, it turns out there's two basic types of AJAX. There's client-server proxy AJAX and client-side rendering AJAX. Client-server proxy is a very popular way of doing AJAX in which you have the server people write the server application, and then there's some magic AJAX stuff that takes the methods that are exposed publicly on the server app and generates JavaScript over here that has a bunch of levers on it. And the levers on that JavaScript are named the same as the levers over here on the server, right? And then the client-side rendering people, all the UI designers, the people with pink hairs and lots of piercing, they don't know how to write Java, but they know how to write JavaScript. They are able to interact with this JavaScript object and pull the levers over here, and then magically state changes on the server, right? That is a client-server proxy. That's how a lot of AJAX works, because it really meets up with how a lot of companies have their development groups, right? The problem of that is that this JavaScript chunk over here that has all these levers has to have those levers up front, right? The moment you start using AJAX functionality, because it's asynchronous, you can't guess what calls happen in what order, right? Because page reloads aren't happening all the time. So you can't guess that somebody gets to step 2 of a step 1, because perhaps all that stuff actually just happens in the rendering. All of the methods that are ever going to be called by the AJAX are often downloaded with the first initial 250K of JavaScript that comes down with the site. And so you end up with a big chunk of AJAX with a listing of all of the methods and all of the parameters it takes and all the stuff it can do. We once did a pen test where they had taken a normal web application and they'd AJAXified it, doing some automatic magic hocus pocus. And our first day, we down and we look in the big chunk of AJAX that comes down, and we're looking at the methods, and it's like log in and transfer money and do this, change password, make me admin. That's an interestingly named method. Make me admin. And it turns out if you call it, your user becomes an administrator on the application. Why'd that exist? Why did make me admin exist in the Web 1.0 app as a parameter that you could put after logging in? I mean, who put that in there? A developer, right? Because they needed a backdoor, because developers aren't allowed accounts on production systems, but they're held accountable for the bugs. And every once in a while, they need to log in as an admin, and so they created a parameter that if you put make me admin equals 1 in any GET request, all of a sudden you became an administrator. Now, if this was a Web 1.0 app and we had pen tested it, we never would have found it, right? Because you have to brute force every stupid phrase in English put together, right? Make me admin, make me root, give me, right? You can't try all that stuff. But in the Web 2.0 world, all that stuff is automatically given to you. And you don't have to do all this stuff. You don't have to walk through. You don't have to spend all day doing enumeration. It just comes down in a nicely formatted list. And Zane's going to show you some examples of what those lists look like. Cross-site scripting. Now, like I said before, the good old days, the only thing dynamic on a website was the HTML, right? Images are obviously generally not dynamic, and JavaScript was only supposed to be for menus and stuff. When JavaScript was invented, the idea was it was a static bit of programming that you download, and the program is the same, although the data input might be different, right? Well, it turns out that's not true. That causes a lot of flaws. But this data now can come in a lot of different ways. So we're going to talk about one possible way that you can do AJAX that has 4 different cross-site scripting injection possibilities. This is the same way Google Maps works, which is upstream we get HTTP gets, and then down. So this is the first initial login. Maybe I go to, this is webmail.com, which is Ajaxified, and I say give me index.html, and so I get index.html and a bunch of JavaScript, and then the JavaScript does asynchronous requests using XML HTTP requests. It doesn't really matter what this format is. And downstream comes evaluable JavaScript. JavaScript that then gets wrapped in the eval statement here, right? So first off, the obvious injection attack against that is that JavaScript is already coming down and being executed. So why don't I just change what that JavaScript does as an attacker? I don't need to create a script tag. I don't need to create a style tag. I don't need the less than or greater than signs. In this case, all I have to do is break out of a JavaScript array. And I need the double quote, which double quote is not something that is sometimes filtered and not sometimes filtered by input filtering. And so in this case, this is code that comes down, gets executed by the client side, and was supposed to do some stuff. I control what's read. So I say, sure, I'll give you something to put into the array. And then I'm going to close the JavaScript statement. I'm going to do bad stuff. Obviously, this is where you actually put your attack code. And then I'm going to put this in here. Why do you think I put this right here as an attacker? Right, because I want the syntax to be correct. They put those double quotes and that semicolon there for me. If I break the syntax, what happens to the JavaScript? It just breaks, right? JavaScript does not have a very robust error model. If this thing was bad, this whole line would not get executed. And so we have to make sure that we make the things that exist to still make sense. As you can see, things like the less than and greater than sign script on mouse over, all that kind of stuff does not exist here, right? So this is injection attack number 1. So maybe they're looking for this injection attack. Maybe they're looking for double quotes, right? So what if I just put like some standard old double script in there, JavaScript, that doesn't have any double quotes in it? Well, anything that comes down that gets written into the HTML, that gets displayed to the user, has to be written into the DHTML, right? There's JavaScript. It takes something from the server, it parses it maybe a little bit, and then it puts it into the page. There's different ways of doing that. And there are, out of the 3 major methods, the methods being document.write, inner HTML, and inner text, 2 of them will, if you write script into the stuff that gets written into the page, will execute the script right after that's done. So if you get something from the server, it runs, and then there's some JavaScript that takes the inbound JSON array and does a document.write to it, then the script tag is going to execute. And if it does an inner.html, the script tag is going to execute. If it does an inner.text, it's not going to. Are you sure 15 minutes? Because other guys went over, and we'd like to actually finish the prezo. Okay. How about we have a vote in 20 minutes if people want us to stop or not? We'll let the people decide. Isn't that what Toorcon's about? The people? So this is cross-site scripting number 2. The third way that the scripting might happen is the cross-site scripting might already be in the DOM. JavaScript and AJAX applications often go to variables defined in the browser and then use them automatically to do some stuff. One of the things they do is they dynamically write links, because using AJAX is a great way that you don't have to rewrite your app to work on qa.webmail.com and production.webmail.com and dev.webmail.com. If your JavaScript just goes through, asks the browser, what URL did I come from, and then rewrites all of the links automatically using that URL.
Is that a MIT's research? Can you do some stuff with?
Yeah, and this is a link to a MIT's web page that has a lot of good lists of variables that can automatically, can be controlled by an attacker. Most of these variables come from the fact that people can send you a link and you click on it, and they can set things like document.url, document.location, document.refer. So in an Ajax, this exists in regular apps too, but in Ajax apps, I think it's more common because people like to do little tricks that rewrite their stuff. So that's the third way of doing it. The fourth way of doing it is the fact that cross-site scripting, that Ajax relies on the fact that there are requests that happen invisibly to the user, right? There are requests that happen on the back end that are never seen by the user and never show up in the URL box in Internet Explorer, right? Those requests are made by XML HTTP request, and the response is handled by XML HTTP request. That response is not handled by the browser. What if the response is handled by the browser? That changes the security model. It changes what the inputs have to do. Let's say we have a webmail.com still. Webmail.com uses this GET request on the back end. After you go and you click on the inbox, it wants to get the list of all the new messages in your inbox. So it makes a request, get all the new messages, and the response is an array, and the array is filled up with lots of data with all the information from the all the mail that you have, right? So obviously this information is controllable by an attacker because they send you email. So an attacker sends a victim an email with a script tag. Maybe it's in the subject line of an email. And maybe webmail.com knows that's a bad thing, so they take any double quotes out of this, right? They don't allow double quotes into this, so you can't break out of the message array. And when they write it in, they use they use intertext, so it doesn't execute, right? So they've thought about this already. Maybe the webmail.com person's leaving, like this gentleman, and doesn't know how this attack works, right? He's only going to know how 3 of them work. Oh, you're vulnerable now. And so an attacker sends the victim an email link. They look at it, and they read the email, and it says in the subject line, script do something bad, right? And they're like, wow, that's a really weird email. And then they go to their next email, which happens to have been sent by the attacker as well, and they click on this link. This is a link that the user never knew existed. It only runs in the back end of Internet Explorer, right? And so the victim clicks on that link, and now they get this as a response. Now this, when wrapped in an eval statement, doesn't do anything, right? What happens though if Internet Explorer gets this down as a document or as a text/HTML MIME type? Anybody want to guess what happens? Sorry? It runs, right? So it looks and says, I don't see an HTML tag, I don't see a body tag, I'm a little confused. I'm not sure what this is, although the MIME type says it's HTML. So I'll go through and I'll treat this as text. And so the user is going to see this stuff as black text in the normal like fixed space font in Internet Explorer. And then it gets to this and it says, oh, a tag, excellent. I am looking at HTML. And it will parse this as a script tag and it will run this script. So this is not run in the context of the actual application itself. It ran because of a link that talked to something on the back end of the application that the user never knew about. But I am guaranteed as the bad guy that this cookie exists because they clicked the link from the email, right? So that makes sense to people? So this is the fourth way. So this is kind of illustration. Cross-site scripting is a little harder in Ajax, right? Because you can't just think of stuff being written in HTML. You have to think about it being written in JavaScript. You have to think about it being written into the DHTML later. And then you have to think about what if it gets looked at directly by a browser because somebody clicks on the link. Oh, and you have to think about what's in the DOM, too. Oops. Okay, so there was a cross-site scripting bug in MySpace. Like I said, that's their entire business model. So there will be more cross-site scripting worms. This is the worm written by Sammy. He was a very, very lonely boy, and he wanted lots of new friends. And the way he thought he'd get these friends is by running script in their browser, which I guess if you are very emotionally stunted, I better not actually insult him because he's going to do something bad to our website. Sammy's a great guy. He's obviously very smart for a 13-year-old. He actually was smarter than the MySpace developers because he actually uses XML HTTP request. He wrote an Ajax worm on a non-Ajax website, which I think is kind of cool. And what this worm did is once you looked at Sammy's page and it had the script on it, it would go modify your page to include his script on it. So anybody that looked at your script page got infected. And then it would add you as his friend. And to add as a friend, he had to get this thing called a hash code and parse it out of the hidden parameters and then put it back into one of the posts. Why is that necessary? Why do they have that hash code in MySpace?
Are you sure you want to update your profile?
Right, so this is to stop an attack called cross-site request forgery or cross-site reference forgery. This is really kind of the new hotness. security, although it's been around for a while. This is an excellent paper written by my partner, my business partner, Jesse Burns. Raise your hand, Jesse. That's Jesse. You can ask him all about XSRF afterwards. Although he mistakenly calls it cross-site reference forgery in this paper, he did not get the memo about what our naming convention was going to be. People call it both. Oh yeah, it's usually abbreviated XSRF or CSRF. That's a typo. Anyway, this is a very interesting vuln. It's almost a universal problem with the websites we look at. What does it let you do? So I'll tell you a true story. One day there was a yuppie, and this yuppie was monitoring his net worth, right? Because the greatest yuppie porn is the stock ticker from Scottrade or Schwab or any of those sites, right? And he had his little stock ticker running in the bottom right corner of his desktop. And so that is a Java application that runs in an Internet Explorer window, and it sits there all day and it says, this is how much money you have, right? And just sits there all day, and that's all it does while he was at work, and he could very happily look at that and see how much money he has, which made him happy, right? While he was doing that, he wanted to make more money, so he wanted to find some inside information to trade on. So he goes to Yahoo Finance, the center of SEC investigations these days, and he goes and reads the message board, and he sees a message saying that I've got some leaked information. And there's a tiny URL, which I'm amazed at anybody clicks on an URL from tinyurl. He clicks on it, and he goes to cybervillains.com/news. He says, wow, this is an interesting name for a news site. But perhaps he's not that concerned because he's actually looking for illegal inside information, so perhaps some cybervillains would know something about it. And he goes and he reads this site, and it doesn't look that interesting to him because it comes from the Washington Post, and everybody here knows the Washington Post is not the paper of record. Where's Brian Krebs? And he reads this story, and he says he gets bored and he closes his window and he leaves. He does not click, nothing pops up. He does not accept any ActiveX control. He does not download anything. He does not say, yes, I want the happy little bunny to download, and then says, yes, Microsoft, I'm an idiot, and I want that unsigned app. Yes, I want to install that ActiveX control. He does not do any of that. All he does is he clicks on a link and he reads a website. Sounds good, right? Maybe he's even running Firefox. He's not running Internet Explorer. Or he's running Safari. Any Mac addicts here? Got one here, yeah. Safari, yeah, Safari's actually worse for this than Firefox. Hate to break your bubble, sorry. Mac's perfect, don't sue me, Apple. Maybe he's running Safari and he clicks it. And he gets bored and he leaves the site, and then a couple weeks later he gets his monthly statement and there's $5,000 missing. Now this is a true story, an absolutely true story, it happened. Both the victim and the attacker worked for us, and this was a penetration test of a stockbroker website. And this is actually, there are multiple financial service institutions that have this vuln. But it really happens, and I know for a fact that it happens to real people as well. What happened while he was doing that? I'm just going to go for the graphic. Well, so he made a GET request to cybervillains.com. Cybervillains.com a bunch of HTML and JavaScript, and it rendered. And he's reading his story up here, and he doesn't notice, because he shouldn't see it, that there's script running on that page, and there's a bunch of hidden iframes. Interesting. And these iframes are populated with form fields that match up the form fields of what you'd normally want to do on stockbroker.com. And what the script does, and oh, remember, he's reading he's got his ticker, right? The ticker is running in a different Internet Explorer window in JavaScript. It's got a cookie, but that cookie is available between all IE windows. Anybody ever notice that, how cookies work across all windows? They use a shared memory section, a memory map file to do that. Firefox is the same with files on the hard drive. All the browsers do that, right? It's got a cookie automatically. And what that script does is it submits these hidden iframes, which are pointed at stockbroker.com. It submits them in order, and the browser says, oh, I'm going to be helpful and attach this cookie to those requests. And what those post requests do in order is change his email notification settings, add a new bank account, transfer $5,000 into that new bank account, delete the bank account, and then change his email notification settings. So while he's reading this, he gets 2 emails saying, your email has changed, your email has changed. And that's all he sees. And this takes about 8-10 seconds, depending on how fast his web connection is. So what happened here is this application, this script, pretended to be him. And this is not a browser bug. This is totally legal. Applications are allowed to do cross-domain posts from iframes with cookies attached. Anybody know what this is used for legitimately? Anybody ever here use SiteMinder or any of the single sign-on applications? This is how single sign-on works often between domains, is that you do a cross-domain post from a hidden iframe with like a SAML assertion or some kind of encrypted cookie, and then the response sets a cookie for the other site, right? This is how you can get from bankofamerica.com to paymybills.com without having to re-log in. Makes sense, right? So this is how it's supposed to work. what is the moral of the story? Well, the first moral of the story is there's no such thing as a browser security model. There is no such thing. There's no book called the browser security model. There's no RFC called the browser security model. What there is there's security decisions made by people sitting in Netscape in 1996 when they implemented some of these features, and those individual engineers who said something like, hey, I want to create this thing called an iframe, right? And I've talked to Tim Berners-Lee about it, and he thinks he's real excited, right? And I don't care about anything else because I have $1 zillion in my bank account. That person who decided how iframes are going to work made some security decisions and wrote them into Netscape 4.05, and we have to live with those security decisions forever. There is no browser security model, and that's a bad thing. Nobody's thinking about this stuff. Lots of people are thinking about this independently, and it's always people that like features, not security. And so that's one of the problems. The other problem is the stockbroker site used form posts, which are pretty easy to falsify. Gets are even easier. Those forms with easily guessed information, there's nothing not guessable in those forms. And they didn't have anything random or encrypted. It's a very, very common issue. Lots of people have it. How about in AJAX sites? In AJAX, it's both better and worse. If upstream communication requires XML HTTP request, it's better. Because for the most part, XML HTTP request only allows you to talk to what your document.domain is set to, and you can't randomly set your document.domain to something else, right? You can only make it go up. So if I'm coming from www.webmail.com, I only set my document.domain to webmail.com. It's the same rules of who can access cookies. So that's smart. XML HTTP request does not do cross-domain stuff. But if your site does gets or posts, which can be falsified either with image tags or script tags, or with iframes doing posts, then you're just as vulnerable. And there's one situation in which you're way, way more vulnerable. And that's if you're doing the upstream request and downstream JavaScript. And actually, some web developers know about this. They know about it, and what this paragraph basically says is this is a great way of doing cross-domain AJAX, but don't tell anybody because we don't want the security people to take it away. Turns out web developers don't think much about security people. But anyway, you are allowed in your site to say, I want to get my script for my website from somewhere else. When you make that request, cookies are sent. Uh-oh. What can that mean? Well, it used to not mean anything, right? Because like I said, script was supposed to be static. Was not supposed to have anything secret in it. But what if the JavaScript does have something important? So, like we have our webmail.com still. These poor guys are getting beat up pretty hard today. And they have upstream GET requests and downstream JavaScript, and the JavaScript has the information that you want in it. In this situation, it's calling a function called addMessage, which takes a bunch of information that comes from the email, calls into a function already defined within webmail.com's JavaScript, and adds the message. Make sense, everybody? Okay, so that's how it's supposed to work. What if an attacker, what if you come to cybervillains.com and I say script.source webmail.com/inbox functions get inbox? That script now goes to a script tag on my cybervillains.com website. Now, I'm not supposed to be able to look at the source of that script again. Okay, well, that's good. But what I can do is I can define a function called addMessage, because I'm targeting webmail.com, and I have a webmail.com account, so I know this exists. I create a function as the bad guy called addMessage, and that function, instead of updating the person's page with all of their email messages, takes all the arguments and sends them to my server. And so I'm now able to read this guy's email across domains when he comes to my site. That's a problem, obviously. It's bad for JSON arrays and raw arrays as well. Jeremiah Grossman figured out that you can override the array constructor. So you can override the array constructor, and then JSON that comes down, instead of creating a real array, you just take all that data and send it to the bad guy. In this situation, if you use AJAX like this, you're way worse for XSRF. So the lessons are, if your requests are guessable, that's bad. You should add cryptographic tokens to your requests. If the requests are formatted simple gets or simple posts, that's bad. You want your request to be something that can only be formatted by XML HTTP request. If the GET request return valid JavaScript to one of those gets or posts, you're really bad because the cryptographic token thing doesn't actually work. If somebody can find one request that doesn't require a token, they can fonts and then perhaps pull the token out of that, right? And if requests are formatted as HTML forms, you're in trouble. And this is something that might get a lot worse because developers want XML HTTP requests to work cross-domain for things like housingmaps.com, which talks to Google and talks to Craigslist. They want to be able to do that all from the JavaScript instead of doing it through the server. And so they want a mechanism for XML HTTP requests to work cross-domain. Now, I'll do this real fast, but there is a mechanism. Flash does this already. Flash has a file called XML, and in that, the webmaster can define these are the places that are allowed to talk to me using Flash, XML HTTP request. And those requests are authenticated with cookies. So that's not a big deal, right? Because the webmaster has control, obviously. The webmaster can control whether they have XSRF or not. But the point is, if you put this into crossdomain.xml, allow access from all the domains, this is basically the web equivalent of putting ++ in host.equip. Anybody remember that SunOS bug, like SunOS 4 or something? They put ++ in host.equip because it makes it easier to deploy Sunboxes and then administrator them, right? It's really easy if everybody on the network's root, right? Well, that's the same statement here. But fortunately, the users have control, and this is well documented, so nobody would do this, right? Well, I'm going to take a little something from Johnny I Hack Stuff and do some Google hacking, and I'm going to search for something, and I'm going to find, it turns out, a bunch of crossdomain.xmls that have this, including perhaps one URL that shouldn't have this in it. People that might need to know better because they've invented this and they own the application. I'm not going to say any names, Eric Lee, but that's a problem. Okay, so we only have a couple minutes left, so Zane is now going to go through the frameworks reasonably quickly, and we'll talk about what the security issues exist in the off-shelf stuff.
So we took a quick look at the Ajax frameworks, a few of the common ones out there, and we didn't do like an in-depth security bake-off between them or anything, but we wanted to see what features, if any, they give to like a normal web developer who's going to just grab this and start applying it. So the first one that we looked at is DWR. DWR you use if you've got an existing Java web app, and what you do is you download DWR and you let it know what methods you want to expose, and then it will create the JavaScript for that. It'll push it down to your clients, and then they contact the DWR servlet, which acts as a proxy, and it pushes the calls onto your existing Java web app. Like Alex had said, what's that? Oh, sorry about that. So because it's a proxy-based framework, all your methods are going to come down in the JavaScript because they have to be exposed to the client. So method discovery in DWR is incredibly simple. If you want to, when you connect to the web app, you'll see traffic like that just come down in a JavaScript file. Look at it and see all the methods that are coming down. Or DWR has a nice little feature where if you just append /DWR after the web app, you'll see something like this, which is all of the methods and all of the classes for the web app, which is quite handy. Cross-site scripting in DWR, traffic comes down, it's just JavaScript traffic downstream, placed in the DOM. There's no built-in filtering with DWR for cross-site scripting. The sample apps that they show you that you can download and set up to run, there's cross-site scripting all over the place. You find it, you trip over it. As far as XSRF, looked like they might have some built-in protections at first. When you're playing with the demo apps, you see a field called call ID there. Turns out that has nothing to do with cross-site request forgery. All right, I'm going to speed through this since we're pretty much out of time. That has nothing to do with, if you can play with that, it offers no protection whatsoever. DWR is, you're going to need to implement your own protections for anything you do with DWR. Sajax, since we're out of time, we're going to skip. Think DWR, but you can't append /Sajax, unfortunately. But with everything else, it's the same. Atlas. Atlas is not a proxy-based one. You download it, you add it into Visual Studio, and then when you go to create a new web app, you use the Atlas web template framework. So method discovery in it, while it is easy to do, you're not going to get all of the methods when you initially connect to the web app. Whenever you go to a page, whatever functionality that page offers, you'll see the methods come down. They're very easy to sniff. You just take a look at them like that traffic. Cross-site scripting, there is a little bit of built-in cross-site scripting protection because it's with the .NET framework. It's not comprehensive by any means, but it offers a little bit, so you should definitely take care of it and definitely use it. Cross-site request because it does upstream posts with XML HTTP requests, those you can't forge. But if your web app uses Atlas and you're using upstream GITs, you're still going to be vulnerable to XSRF. You're going to need to implement your own protections for that. However, it's not really a security feature, but because Atlas's serialization looks so weird on the wire, it's much harder to do an XSRF attack, but that's just because it's more obfuscated. Google Web Toolkit, also for an existing Java web app, but it's not a proxy situation. You run Google Web Toolkit on your existing Java web app. It compiles it into JavaScript, which then you can just push down from static web server. Method discovery in it is hideous. Several hundred K of that. It comes down to .cache.html file. It's hideous compared to all the other ones. Cross-site scripting, similar to cross-site request forgery with Atlas. The traffic is really the serialization is just ugly, which makes attacks much harder to do. We played around with it, and cross-site scripting is certainly possible, but the bar is definitely raised. Okay, we're out of time, so I'm just going to do conclusions real quick and kick it back to Alex. Conclusions, only Atlas is going to offer a little bit of protection. You should use whatever's there. And with all of these, you're definitely going to need to understand how the traffic looks on the wire and implement your own protections for them. They're not going to be a silver bullet for you. So let me kick it back to Alex.
Okay, sorry about that, Zane. Okay, so what is the future trends in AJAX security? We are moving to a web-based OS. Think about what percentage of your day that you do important stuff that you do in your web browser. It's a significant amount, right? We're getting to the point where I don't really care if I get a rootkit on your machine because you do everything on the web. Nobody logs into their bank account from their desktop anymore, right? They log into their bank account from the web. They trade stocks from the web. They go and make appointments with their doctors from the web. They interact with all their 13-year-old friends from the web. That's all stuff that happens in a browser now. The problem is that browser, like I said, there's no such thing as a browser security model. There's a JavaScript security model that says JavaScript's not allowed to interact with the desktop OS in these ways, but JavaScript has no internal security model. And we're moving to kind of a web-based OS, which perhaps is the world domination plan of a certain company that starts with G and ends with Google. If you go to things like Google Personalized Homepage or WindowsLive.com, they advertise the fact that you put plugins or gadgets, they have different trademark names for it, you can put plugins or gadgets into your page. This is stuff like a little applet that says what the weather is, or what the time is, or what your friend's Xbox Live gamer tags look like, right? That is JavaScript written by a 13-year-old in somebody's basement that is then advertised by Google and Microsoft to say, please include this in your homepage. Oh, they're cutting me off. Do you want us to stop right now? We've got one more slide. I don't know that guy. Anyway, web desktops, because of this issue, this is scary, right? Because there's no way to run a low rights user in JavaScript. There's no such thing as low rights JavaScript. JavaScript is JavaScript. And if it's running, it's bad. Who owns this page? It says live.com, which belongs to Microsoft, but the content on this page comes from a bunch of different people. This content can include executable code that does all this crazy stuff in your browser. This is the same cookie you use to log into Hotmail. It might be the same that you use to log into MSN Money and see your stock portfolio. This should be frightening, right? For all of these federated web apps that use the same login, but then allow you to plug other people's RSS in and other people's script in. Who is responsible? There is no security model in here. Remember that. Everything that's included in here can do anything the hell it wants. So AJAX is fine, but like other technologies, developers have to understand it to secure it, and right now they don't know how to do that. All the old web attacks still exist, but they're more interesting, and there's work left for security researchers that want to do stuff in here. Web security is no longer the red-headed stepchild. We used to be looked down upon because we don't write shellcode in JavaScript, so we're not cool, right? We don't get the black t-shirts. We shouldn't be real security researchers. That's not true anymore. So if you want to do security research in web apps, please let me know. There's lots of stuff you can do. Great. Thank you very much for coming. We'll be around to answer questions if you want. Sorry about that.
Oh, no worries. And we'll be starting up here in just a minute. Just so you guys know, there's a bar outside, so if you want to go grab a beverage real quick to come back in for the next talk, please do so. Oh. Hey, and you guys let Zane get away without releasing his Cheerio day, so you guys should get on his case to drink his beer.
Yeah, totally. Do you guys have it? Why don't you tell everyone we're going to start 10 minutes after? Because if they all went out for beer, I don't want to lose them.
Yeah, I'm sorry.